Okay, so here we have two vectors, 3i hat plus 4j hat, and 2i hat plus 5j hat. And I've drawn these on this coordinate system here. So here's my vector A, 3 in the x direction and then 4 up. And B is going to be 2 in the x direction and then 5 up. Okay? So here's what I want to know. If I want to create some new vector C that is the sum of A plus B, what is that going to be? And so there are really three different questions we can ask. What are the components of C? What is the magnitude of C? And what is the angle of C? Okay, what is the direction of C? So those are the three questions we can ask. Now, the components are extremely easy. Okay, the components are extremely easy. To add your components, the components of C are just going to be the individual components in that direction. So the x component of C is just going to be the x component of A plus the x component of B, and the y component of C are just going to be the sum of the y components of A and B. Okay, so for example, if I add these, then I'm just going to add straight down, and I'm going to say 5 plus 9. And again, I'm going to include my hats. So 5 and 9, okay? And so if I were to plot my new vector, okay, then I would go 5, and then up 9, and I need one more, right? I need one more tick right there. Up here, all right? So this is Cx, this is Cy, and I'm going to draw a dotted line here. That is C, okay? That new dotted vector is C. Now, graphically, what does this look like? Well, remember the tip to tail method. Okay, so what I can do is, if I want to add this graphically, then what I can do is take my B vector, and I can take my B vector and move it around, but I'm going to move it such that its tail is at the tip of A, and if I do that, then if I displace B, I will displace it such that, follow, it arrives right at that new point. I need a straight edge, okay? So they both end up at the same place, okay? If I draw my resultant, and by the way, okay, this is called the resultant, okay? This new vector is called the resultant. If I add two vectors together, then the new vector that I obtain is called the resultant. So my resultant, if I just look at the components of the resultant and find the vector, or if I graphically add my two original vectors, I arrive at the same spot. Now, here's another trick, okay? Does it matter which vector I displace? It turns out no. I could just as easily have displaced A, and notice if I displace A such that its tail is at the tip of B, then I also arrive right at the same spot. Okay? So it does not matter which vector I displace. Okay, I'm still going to get the same. All right? So what we would typically do at this point is then erase my individual vectors and just leave the vector C up on the graph, okay? And then you can either measure this with a ruler to get the magnitude, or you can use the Pythagorean theorem that we used earlier. So to get the magnitude of C, okay? If you add that up, you should find that your resultant is approximately 10.2. Okay, just off the top of my head, if I take the square root of 106, that's probably around 10.2. It might be a little bit more, it might be a little bit less, but as an approximation, that should be pretty good. Okay, now one other thing to note. Well, let's do the resultant, or the direction first, right? Let's do the direction first. So the direction, if I just have, and now I am going to erase all of these individual vectors, and now we'll just redraw the resultant C, okay? So here's C with a magnitude of about 10.2. This had a length of 5. This had a length of 9. Okay. Once again, we're typically going to measure our direction with respect to the x-axis. So tan theta is going to be equal to 9 over 5. And theta is going to be equal to the inverse tangent of 9 over 5, right? And that'll give you some angle, okay? Probably somewhere around 60 or 70 degrees, okay? But, okay, we've now found the components, the magnitude, and the direction, okay? Now, one thing that I should note